for today's lesson, we will be discussing about the truth tables. So we will be discussing the truth values as well, and we will be constructing the truth tables of compound and conditional propositions. So let's define first what is a truth value. So the truth value is the truth or falsity of a proposition. So the truth table can be used to summarize the truth values of the proposition. So when we say truth value, there can only be two choices. It can be true or false only. So we use now the truth table to summarize our truth values, because we have, or we can assign different truth values for each proposition. So we will be considering all the possible values of each proposition, and we will write it all in a truth table. So let's discuss first what are the different truth values for each compound proposition. For the conjunction P and Q to be true, both P and Q must be true as well. Otherwise, it is false. Since we need to consider both of the statements, since we connect them by and, so the two must have the same truth value so that we can say that they are true. Otherwise, it is false. So both P and Q must be true so that we can say that the conjunction P and Q is true as well. For the disjunction P or Q to be true, either P or Q must be true. So for us to say that the disjunction P or Q is true, either one of the P or Q must be true as well. So as long as there is one true proposition between P and Q, or P or Q, then we can say that the disjunction P or Q is already true. Otherwise, it is false. For the negation, not P, it is opposite of the truth value of P. So if P is true, then its negation is false. If P is false, then its negation is true. So here is the truth table for our conjunction, disjunction, and also for the negation of statement. So let's say we have here P and Q, which are our two propositions, and then we just have to consider all of the pairs for the truth values. So we can say that the first one is true, Q is true. We can also say that P is true while Q is false. We can now also say that P is false and then Q is true, or both of them are false. So you have to write all of the possible combinations here. And then we have here this one, P and Q. This one is for the conjunction. So remember, for the conjunction to be true, both P and Q must be true as well. So here we have true and true. That's why the conjunction P and Q is true. Then for this one, we have true and false. Since they are different, that means the conjunction is false. Same as with the third one. This one is false, this one is true. Since they are different, so the conjunction is false. And then for the last one, both of them are false, so automatic, the conjunction is false as well. So remember, the only time that the conjunction will be true is when both of the statements are true. Otherwise, it is false. Now for the disjunction, all we have to do is just to look for a true proposition here. So in the first one, we have true, and then we have true as well. So therefore, the P or Q is true. Second one, we have true, we have false. Though they are different, but since this is disjunction, that means either of the two can be true. So therefore, the disjunction P or Q is still true. Same case with the third one, it's false and true, so the disjunction is still true. The only time that our disjunction will be false is when both of our statements are false. So false and false, so the disjunction is also false. So that's the only time that our disjunction will be false, when two of our statements, or if P and Q are both false. Otherwise, it is true. And for the negation, all you have to do is just to change the truth value of the original proposition. So we have negation of P. So we have to look at P. So true and true becomes now false, false. And then the two false here becomes now true, true. Now, for the truth value of a conditional proposition, P, if P then Q, if the antecedent is true, then the consequent must also be true. Okay, so that is one thing that we have to remember. If the antecedent is true, then our consequent must also be true. So that we can say that the whole implication or the whole conditional proposition is true. Otherwise, it's false. So to visualize or to understand even more the truth values for conditional propositions or conditional statements, let's have this example. A person makes the promise, if I find a 50 peso bill, then I will take you to a movie. Now, we consider when the person has broken the promise. So, let us list down here the different possibilities of our statements. So, this one, remember, this is our P. This is the first statement. And then this one is Q. So, we will try to reconstruct the statement. And we will also change the truth values of P and Q. So, first one, the person finds a 50 peso bill and takes you to a movie. So, this one now is our P, or the first statement. So, it says that the person finds a 50 peso bill. So, our P is true. And he takes you to a movie. So, the Q here is also true. So, if both of our antecedent and consequent are true, like in this case, therefore, we can say that the implication is true. Or P implies Q is true, since the person did not break the promise. So again, note, P and Q here are both true. So if both P and Q are true, or both our antecedent and consequent are true, then we can say that the conditional proposition is also true. Another statement, the person finds a 50 peso bill but does not take you to a movie. So in this case, the antecedent is true because the person really finds a 50 peso bill, but the consequent now is false because that person does not take you to a movie. Okay? So, as you can see here, the person broke the promise because as the person finds a 50 peso bill, but that person did not take you to a movie. So this now, our conditional proposition is false. Remember from the previous slide, if the antecedent is true, the consequent must also be true. If it's false, like in this case, then that means the implication or the conditional proposition is false. Okay? Next, the person did not find a 50 peso bill but takes you to a movie. So here, the antecedent is now false because the person was not able to find a 50 peso bill. But that person takes you to the movie anyway. So the antecedent is true. So since the person did not break the promise, that means our implication is true, or the conditional statement is true. So it is true even though the antecedent is false, but the corresponding consequent is true. That makes our implication true as well. And lastly, we can write the person did not find a 50 peso bill and did not take you to a movie. So in this case, the person did not find a 50 peso bill, so that's false. And did not take you to a movie as well, so that's false also. But even though both of our antecedent and consequent are false, the person did not break the promise, because the promise is that if the person find a 50 peso bill, then that's the time that the person will take you to a movie. But since the promise was not broken by the person, so that means our implication or the conditional statement is still true. So in this case, it will also be true given that the antecedent is false and the consequent is false. So the only time that our implication or the conditional proposition will be false is when the antecedent is true and the consequent is false. Otherwise, everything will be true. For the truth value of a biconditional proposition, P if and only if Q, if the antecedent is true, then the consequent must also be true. And if the antecedent is false, then the consequent must also be false. Since it is if and only if, that means it's a two-way. Therefore, both the consequent and antecedent must have the same truth value before we can say that they are true. So that means the antecedent and the consequent must have the same truth value so that we can say that the given biconditional proposition is also true. So, same truth value. Then we can say that our biconditional proposition is true. So the antecedent is true, the consequent is true, therefore the biconditional proposition is true. The antecedent is false, the consequent is false, therefore the biconditional proposition is still true. Now, if they are different, one is true, one is false, then that's the time that our biconditional proposition will be false. So this is the truth table for the biconditional and also for the conditional propositions. So we still have P and Q here. So again, you designate values for our P and Q, all the possible values of the propositions. And then for the implication or for the conditional statement, P, if P then Q, so again, it will only be false if the antecedent is true and the consequent is false. So that's the only time that your conditional proposition is false. Otherwise, it will be true. And then for our biconditional proposition, it will only be true given that our propositions have the same truth value. So if they are both true, the biconditional is true. If they are both false, then the biconditional is also true. If they are different, then you will get false value for our biconditional statement. In logic, we also have what we call as the tautology. So it is a formula which is always true. That is, it is true for every assignment of truth values to its simple components. You can think of a tautology as a rule of logic. So when you say tautology, that means all of the truth values at the end of our truth table will be true or should be true. So you will see later on everything and the last column is true, then we will say it's tautology. The opposite of that is what we call as contradiction. This will happen if everything or all of the truth values at the end of the column of our truth table is false. Okay? So in other words, a contradiction is false for every assignment of truth values to its simple components. And if it's a combination of two, if it's true or false, so we call it contingency. So again, if everything is true, so that is tautology. If everything is false, then it is contradiction. If it's a combination of the two, then it's called contingency. So let's say we have here this statement. We have P, I will go to the market. Q, I will play computer games. So we have here the argument P or Q and not P. So if I will just write it into in words, so we can have here I will go to the market. Or I will play computer games. And then we have to get not P. And I will not go to the market. So this is the statement or the argument. I will go to the market or I will play computer games and I will not go to the market. So we will see later on in the truth table when will be this statement become true or false. So let's create now our truth table. So in our truth table, of course, you have here the assigned variables for each proposition. So we have P, we have Q, and then we have here P or Q, which comes from here, from this one. And then we also have not P. And of course, the last part is the argument itself. So we have P or Q and not P. Now to begin with, we will assign values for P and Q. So we have to list down all the possible combinations. So it can be both of them are true. It can be this one is true, then Q is false. Or P is false and then Q is true. Or both of them are false. Then after that, let's now write here the truth values for P or Q. So we will be getting the disjunction of P and Q. So we have both of them are true, but since this one is disjunction, so that means it is true. One of them is true, one of them is false, so that means this one is also true. For the third one, this one is false and then Q is true. Still, that will give us a true value for our disjunction. And then lastly, since both of them are false, then that's the only time that our disjunction will be false. So this is now the truth values for P or Q. Now let's get the truth values for not P. So all we have to do is just to get the opposite of P. So we have true, so let's make it false. Next, we have true again, false. And then we have two false here, so let's write here true. And then lastly, let's try to get the conjunction of these two statements here. Okay, so since the operation here is this one. So we have true and false. So that means the conjunction is false. Remember the rules in conjunction. The only time that it will be true is when both the statements are true. So we have another true and false here. So that means the conjunction is false. Now we have here true and true. So both of the statements are true. Then that's the time that our conjunction is true. And then lastly, false and true. So that means our conjunction is still false. So these are now the truth values of our statement, P or Q and not P. So as you notice, we have 3 false and then 1 statement. So the only time that our statement or this argument will be true is when P is false and Q is true. So that is the only time that our statement will be true as well. The rest of the combinations, our argument will be false. Next, I will join the math club. I will join the Glee club. So let's write it again. This is the argument. Let's write it in sentence. So we have not A and not B. So you can write it, I will not join the math club, or I will not join the Glee club. Or you can just write, I will not join both the math club and Glee club, or, and then let's followed by this one, I will join either, so let's write it, I will join either the math club or Glee club. So that is now the sentence form. I will join both the math club and Glee club, or I will join either the math club or the Glee club. Okay, by the way, this one, I will not. So this one should be not. I will not join, because this one is negation. Okay. So I will not join both the math club and Glee club, or I will join either the math club or Glee club. So let's look at the truth values here. So we have again A and B for our two propositions. We have not A and not B because of this one. Then we get the conjunction of that. So we have not A and not B, which is for this one. And then we have A or B, or the disjunction. And then lastly is our whole statement. So let's write here, assign again values, true, 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 false, false, true, false, false. Now you get the negation of A, so that will be false, false, true, true. And then for B, you get the negation of B, so false, true, false, true. Okay? And then after you get the negation, let's now get the conjunction of not A and not B. So since this was conjunction, again, the only time that our conjunction will be true is when both of the statements are true. Otherwise, it's false. So this one, both of them are false. So that means the conjunction is false. One of them is true, one of them is false. So still we have false here. Same case with the third one. Still false. And lastly, we have here both of them are true. So that's the time that our conjunction is true. And then, let's have A or B. So, let's look at this two right here. So, in disjunction, the only time that the disjunction will be false is when both of the statements are false. Otherwise, it is true. So, we have both true here. So, that means the disjunction of A, B is true. One is true, one is false. So, still, we'll get a true for the disjunction. Same case with the third one. And the only time that it will be false is at this point wherein both A and B are false. So this one now is false. And then lastly, let's now get the disjunction of these two statements here. So we'll be getting the disjunction. So the only time that it will be false is when both the statements are false. But looking at the list of truth values here, each of them, they have at least one true for the truth values. So therefore, this one is true as well, false true, true also, true false, true. So all of the truth values here are true. So therefore, we have here a tautology. Since all of the truth values that we get on the last column are all true, that means for all the cases, it will lead us still to a true statement. So there is no combination here that will give us a false statement. So let's have another one. For A, it rains today, and then B, the university will close. So what we will do here, let's try to write them first in sentence form so that you can also practice. So A, it rains today, or the university will close. If and only if the university will not close. Okay? It rains today or the university will close if and only if the university will not close. So let's see here for the truth values of our argument. So we have here again A, B. So this is true, 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 false, false, true, and false, false. So we have here A or B. So we're getting again the disjunction of A and B. So remember, the only time that the disjunction will be false is when both the statements are false. So this one, both of them are true, so the disjunction is true. One is true, one is false, the disjunction is also true. One is false, one is true, the disjunction is still true. And since both of them here are false, then that's the time that the disjunction will be false. And then for not B, so you just have to get the opposite of the truth values for B. So we have here false. For the false, it will become true, and then we have false, and then true as well. And then last, we have to get now the biconditional of these two right here. And so it's if and only if. So remember, in biconditional proposition, the only time that it will be true is when both the statements have the same truth value. So our biconditional proposition will be true if both antecedent and consequent are true, or both of them are false. So in this case, let's see. This one is true, this one is false. So that makes the biconditional proposition false. This one, we have both of them are true. So that means our biconditional proposition is true. These two right here, they are different. So this is false. Last one are different as well. So this one is false. Okay? So the only time that we will get true as the truth value of our argument is when A is true and B is false. So that's the only time that we will get true as the truth value of our argument. So that means this A should be true, the B should be false, so that we will arrive at a true statement when we consider this given argument. And for our last example, let's say we have P, it is sunny, Q, Ben will go biking. So we have here P and not P and Q. So if I will write this in sentence form, it is sunny and it is not sunny and Ben will go biking. There. So that is the statement. It is sunny and it is not sunny and Ben will go biking. So let's see when will be this statement true or false. So let's use again the truth table. So here we have P and Q. So let's write true, 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 false, false, true, and false, false. Okay, so let's get not P. So we have here false, false, true, and true. And we have here not P and Q. So this is not P, then this is Q. So let's get the conjunction of the two. So again, for conjunction, the only time that it will be true is when both of the statements are true. Otherwise, it's false. Since they are different values here, one is true, one is false, the conjunction is false. Next, since both of them here are false, so obviously the conjunction will be false. Now here, both Q and not P are true, so that's the only time that our conjunction will be true. And then lastly, we have F or false and true, so that means the conjunction is again false. And then after that, we will now get P and not P and Q. So we will be getting this two right here. And we'll be getting again the conjunction of that. So we have true, we have false. So that means the conjunction is false because they are different values. We have true, we have false. So that means that is also false. We have false, we have true. So that means it's also false. We have false, we have false. So obviously the conjunction will be false. Now as you notice, all of the truth values here that we got are all false. So that means this will fall under contradiction. That means our statement here is showing a contradiction. This means any value of our P and Q, it can be true or false. P can be true, it can also be false, same as with Q. We will still arrive at a false statement because all of the combination from this truth table, all of the combination here will arrive at a false statement. So that is how you create truth tables for the given arguments. Okay? So that's it for today. I hope you learned something about the truth values, also how to construct truth table, and see you next time.